The Three Gorges Dam in China is the largest power station ever built. It generates an incredible 22,500 megawatts of electricity, surpassing the total output of many entire nations. This monumental project is not just about size, it has even subtly shifted the planet's rotation. The massive water displacement has lengthened our days by a few microseconds. Now, consider Africa, where a project aims to dwarf this scale entirely. This is the Grand Inga Dam, a massive undertaking in the Democratic Republic of the Congo. Designed to produce 40,000 megawatts, it would double the capacity of the Three Gorges Dam.
The Congo River is the second largest in the world by volume, trailing only the Amazon.
Its flow remains incredibly stable year-round, as it crosses the equator and receives consistent rainfall.
Near the coast, the river encounters Inga Falls, a series of powerful, steep rapids. This natural drop creates a massive energy potential, waiting to be harnessed. With 42,000 megawatts of potential, it could provide 1/3 of Africa's current electricity needs. Most dams require massive artificial reservoirs, but the Congo offers a unique, natural setup. Engineers can divert the river's flow through turbines directly, minimizing the need for flooding vast lands. Two smaller dams, Inga First and II, already exist here, built in the 1970s and 1980s.
Together, they only generate a fraction of the river's immense power, leaving a massive gap.
The Grand Inga project aims to fill this gap in multiple, massive stages.
The first phase, Inga 3, is expected to generate over 10,000 megawatts of power.
However, the full plan involves several expansions to reach the project's ultimate capacity.
The estimated cost ranges from $80 to over $100 billion, making it a historic infrastructure project. The Grand Inga project aims to fill this gap in multiple, massive stages. This is where Chinese companies, like the China Three Gorges Corporation, bring their expertise.
They are joined by major international partners, forming massive consortia to manage the project.
Experience with mega dams is crucial, as construction involves extreme conditions and complex engineering.
Building a dam is one challenge. Building the largest one ever planned is something else entirely. These companies bring financing models, technical expertise, and long-term project management skills. European companies, African institutions, and international lenders have also shown interest in the project.
Some deals have moved forward, while others collapsed, and many remain under negotiation. It's a complex mix of partnerships, competition, and shifting agreements. The engineering behind Grand Inga is on a completely different level than traditional dams. Instead of a massive artificial reservoir, engineers plan to divert part of the Congo River's flow.
This water is then directed into turbines at extremely high speeds to generate electricity.
This approach allows the project to take advantage of the river's natural drop at Inga Falls.
It also reduces the need for flooding vast areas of land, a major issue with many large dams.
At the center of the system are massive turbines, each capable of generating hundreds of megawatts. Some estimates suggest individual units could exceed 700 megawatts per turbine.
Some designs also include underground powerhouses, which improve protection and efficiency. Generating electricity is only half the challenge.
The bigger question is how to deliver it.
Most regions that need this power are located thousands of kilometers away. The project requires an extensive network of high-voltage transmission lines across multiple countries.
This means building systems that stretch from Central Africa all the way to Southern Africa.
This includes major energy markets like South Africa, which has faced repeated power shortages. Power losses over long distances and grid stability are critical challenges to solve.
So, is building the dam the hardest part? The answer is no.
Generating electricity is step one. Moving it across an entire continent is the real challenge. Many countries in Africa today have very low national power capacities. A single project like Grand Inga could produce more electricity than dozens of countries combined.
The plan is to export electricity across the continent to power various industries.
South Africa is one of the largest expected buyers, needing a stable supply for its industries.
Currently, many businesses rely on expensive diesel generators to keep running.
This increases costs and limits production, making large-scale industry difficult to sustain. The Grand Inga aims to change that by providing high-volume, consistent power.
But for a project of this size, the benefits are clear, and so are the risks.
The region has faced decades of political instability and governance issues.
Large infrastructure projects need long-term stability because construction alone takes years. Without that stability, timelines slip, costs increase, and investors become cautious. Financing is also a huge hurdle for such a massive project.
Investors need guarantees, such as long-term agreements from countries that will buy the power.
Without those agreements, financing becomes difficult, no matter how strong the plan is. Finally, there is the challenge of governance and transparency. Such a large project involves billions of dollars and long timelines, creating risks of corruption.
So what is the biggest challenge here? It's everything happening around the engineering.
If the potential has been known for decades, why hasn't this project moved forward?
Right now, the project is still in the pre-construction phase, specifically focused on Inga 3. Over the years, the project has seen multiple restarts, cancellations, and redesigns. But funding is slowly coming back, with renewed interest from international partners. The World Bank has re-entered the project, committing millions for studies and early development. However, it is important to note that the World Bank previously pulled out in 2016. This shows how sensitive and complex this project is. The first phase is expected to be completed by 2035. This timeline depends heavily on securing full financing and finalizing construction contracts.
Recent discussions with international partners have revived momentum on Inga 3. In 3.
Some proposals focus on smaller initial builds to reduce risk. If the Grand Inga Dam is completed as planned, the impact would be massive. Reliable electricity allows industries to grow, and manufacturing becomes possible at scale. Mining operations could process raw materials locally instead of exporting them. Cities could expand with fewer constraints. The nation could move from being resource-rich but underpowered to an energy hub. So now the question is, can one project really power such a large part of Africa? If China plays a major role, what does that mean for the future of energy across the continent?
Let us know your thoughts in the comments below.